During the first interval in freefall, the only force acting on the bungee jumper is gravity. This is what the force diagram would look like. According to Newton's first law, if there is an unbalanced force, and in this case, one single constant force, then there will be a constant acceleration. In this first interval, the bungee jumper will be speeding up with a constant downward acceleration of 9.8 meters per second squared, the acceleration of gravity.
When we reach the second interval, gravity is no longer the only force acting on the jumper. Because the cord is starting to stretch, it creates an upward force of tension. During this interval, the tension force is greater than the force of gravity. Thus, the acceleration is now in the upward direction, as seen in our force diagram. Because the jumper is moving downward, but the acceleration is upward, the bungee jumper is now going down with a constant acceleration. However, as the cord stretches, the force of tension increases. This leads to a non-constant force, which results in a non-constant acceleration.
During the third interval, the elastic cord is retracting, causing the bungee jumper to fling upward. In the time before the cord reaches a length,
This happened. They are the outer ear, the middle ear, and the inner ear. The outer ear is made up of the pinna and the ear canal. These parts gather sounds from the environment and funnel them into the middle ear. The middle ear takes these sounds and turns them into vibrations. Sounds that come into the middle ear hit the eardrum, causing it to move. The eustachian tube helps the eardrum to work well by keeping the air pressure balanced on both sides. When the eardrum moves, it makes three small bones called ossicles vibrate. The vibrations are then sent to the inner ear. The inner ear receives vibrations and changes them into messages that go to the brain. These messages are called nerve signals. The inner ear is made up of the cochlea and the vestibule, which includes the semicircular canals. The cochlea has fluid in it that moves like a wave. This happens when vibrations come in from the middle ear. The moving fluid causes hair cells to make nerve signals about sound. Semicircular canals also use moving fluid to create nerve signals that help with balance. Then, the signals from the cochlea travel along the auditory nerve. Signals from the semicircular canals go along the vestibular nerve. These two nerves come together and lead to the brain. There, the brain decodes the signals to get information about sound.